everyone. I'm Dr. Rizwana, working as Professor of Physics in Institute of Aeronautical Engineering. In my last video, I have discussed about attenuation in optical fibers. That is nothing but power loss during propagation of information through optical fibers, and we have seen what are the different types of attenuation losses, and then we have seen the unit for measuring attenuation in optical fiber. Now today in our video, we are going to discuss optical fiber communication system, and then we are going to discuss some of the advantages of optical fibers, and then we are going to do some numerical problems in optical fiber. In optical fiber, what is an optical fiber? It's a cable which is used in communication. And what is the medium through which we are sending our information? That medium is fiber medium. And what type of information can be transmitted through optical fibers? That information, it has to be in light form, optical form. We can send any information, but that information, it has to be in optical form if we have to send through optical fibers. So we can see that suppose if we are trying to send my voice, so what I have to do first, I have to convert my voice into optical form. Then I have to make it go through optical fiber. Then at the other end, that person who is there at the other end, for him to hear my voice again, that my information in optical form has to be converted back into voice. So all this setup will give rise to optical fiber communication system. So now we are going to discuss block diagram of this optical fiber communication system, and we are going to discuss in detail different parts of this communication system. Now if you take any optical fiber communication system, it consists of 5 parts. Essentially it consists of 5 parts. Okay, what is that first part? First part, it is called as encoder. Then we have transmitter, and then we have optical fiber or waveguide, and then we have receiver, and the last part is decoder. So if you take any optical fiber communication system, it consists of 5 parts. What are those 5 parts? Encoder, transmitter, optical fiber, receiver, and decoder. So now if you see this figure, in this figure, all these parts are visible. Now first we have our encoder, okay, and then we have this transmitter. This is our encoder, then followed by transmitter, and then we have our optical fiber or waveguide through which we are sending our information, and then we have our receiver at the other end of optical fiber, and final part, our optical fiber communication system is decoder. Okay, now we'll see what is the functioning of this each part. Now first we'll come to encoder. Now if you see here, what is the role played by encoder? Encoder, actually it's an electronic circuit. So it's an electronic circuit, and what this electronic circuit will do, it will encode that information into binary sequences, that is zeros and 1. So if you see here, what is the role played by encoder? Suppose I am sending analog input. What do you mean by analog input? Analog input means your crude information, okay, like voice. It can be figures, and then it can be objects, okay, or even your television. So when you take all these analog information, so what this encoder will do, all that analog information, it will convert into binary data. What do you mean by binary data? 0 and 1 pulses. So it consists of 0 and 1 pulses. So it will convert them into binary data, or we can also say that it will convert our analog information into electrical pulses. What is the first role played by this encoder? This encoder, it is going to convert our analog information into electrical form. That is nothing but our binary data, 0 and 1. So whatever analog data, suppose I am sending my voice. So first what is done, it is converted into electrical signals, and this is done by encoder. What is our encoder? Encoder, it's an electronic circuit which will convert analog information into electrical signals, or it will convert them into binary data. Then comes the role of transmitter. So if you take this transmitter, it consists of 2 parts. So first part is driver, and second one is light source. So what this driver is going to do, so here whatever the electrical signal we are getting out of encoder, we'll give it to transmitter. And this transmitter, it consists of drive circuit and light source. And what drive circuit will do, it will drive the light circuit source. What do you mean by drive the light circuit source? This driver, it will put all those electrical signals in required form, in proper form, in sequential form, and it will give them to light source. Okay, it will put them into sequential form and then it will give to light source. Now, what is the role played by this light source? In light source, we'll make use of either laser, usually laser, or we can make use of even laser diode also. And what is the role played by laser or laser diode? So this laser source or laser diode, it will convert those electrical signals into optical signals. That is the role played by this light source. So finally, an information is converted into optical form. So out of our transmitter, we'll have our information in optical form or optical signals. So encoder, first it will convert our analog data into binary data. Transmitter, it will convert that binary data into optical form. Now next comes the role of third part, that is optical fiber. With the help of suitable connectors, source to fiber connectors, we'll inject this information in the form of light signals into the optical fiber. We'll inject this information into the optical fiber. Now what happens here, that information, once it goes through the optical fiber, we know that what will happen, this optical fiber cable, it will carry that information over long distances from one place to other place with minimum transmission loss. So it will carry that information over long distance with negligible loss. Okay, once our information is being transmitted through optical fiber, okay, after the role played by this optical fiber, then what is there at the other end of optical fiber? Again, of course, we have these connectors. These connectors are fiber to detector connector. And then comes our fourth part, that is nothing but receiver. Now our information, it is in the form of optical signal. Suppose I have sent my voice. Now, for the person on the other end of optical fiber, he has to hear my voice. So I think he is not able to hear my voice if it is in optical form. So what we have to do now, again we have to convert our information in optical form back to its original form, that is nothing but analog form. So now what receiver will do, again this receiver, as you can see, it consists of two parts. One is light detector or amplifier. This light detector, it is also called as photodetector or photodiode. Now this photodiode is completely opposite to laser diode or laser. What laser will do, laser or laser diode, it will convert electrical input into optical output, light output. But what is the role of photodiode? In photodiode, it will convert optical input into electrical output. Okay, and usually in laser diodes or in lasers, we'll use forward bias diodes. But here we'll make use of forward bias diodes, and those diodes, they are made up of some special type of materials. What are those special type of materials? They are called as direct band gap materials like gallium arsenide, indium phosphide, and so on. Whereas if you take your photodiode, it's a reverse bias diode, and this diode, it is made up of our normal elemental semiconductors like silicon and germanium. So here this photodiode, it is made up of silicon and germanium, whereas our laser diode, it is made up of some special materials like gallium arsenide and indium phosphide. So here it will convert electrical input to optical output. Here it will convert optical input to electrical output. Okay, so light detector, that is nothing but photodiode, it will convert those optical signals into electrical signals. So we have our electrical signals. Here we got our optical signals. It will convert those optical signals into electrical signals. Then we have second part of receiver, that is nothing but amplifier. And what is the role played by amplifier? This amplifier, because they are traveling very far over long distances, they may become weak in amplitude. I'm talking about amplitude, not any loss. So as they become weak in amplitude, this amplifies the signals. After amplifying these electrical signals, it will give them to fifth part or optical fiber communication system, that is nothing but decoder. So what is the fifth part of our communication system? Decoder. And decoder is completely opposite to encoder. As you can see, what encoder has done, it has converted analog information into binary information. And what is the role played by decoder? It will convert those binary information or electrical signals back to its original form. That is nothing but analog form, which is nothing but my voice. Okay. So again, we'll try to quickly revise different parts of this optical fiber communication system. So in optical fiber communication system, we have our encoder. In encoder, we can convert our analog input into electrical signals. And then we have our transmitter. In transmitter, our light source, which is a forward bias diode made of some special type of materials. It will convert those electrical signals into optical signals, and these optical signals are fed into these optical fiber cable or waveguide, and it will travel long distances. Then what we have at the other end of optical fiber, we have our receiver. In receiver, we have photodiode, which is a reverse bias diode made of elemental semiconductors like silicon and germanium. It will convert those optical signals into electrical signals, and they are amplified, and then they are fed to fifth part, our optical fiber communication system, which is nothing but decoder. And this decoder, it will convert those electrical signals back to our original analog information. So this is the part played by optical fiber communication system. So I think all these parts we have discussed in detail. Optical fiber, it transmits optical pulses. Receiver receives optical pulses and converts them into electrical pulses, and then decoder, it will amplify whatever amplified signals are given to it. It is decoded or it is converted back into binary information. So this is about optical fiber communication system. Now next, why we have to go for optical fiber communication system? I think in my first video when I am discussing about optical fibers, I told you in detail why we are going for optical fiber communication system. Now here we are trying to study in detail some of the attractive features of optical fiber communication compared to normal coaxial copper cable communication. So these fiber optics, they have got many number of attractive features. So as you can see in the list, here I have around 9 features. What is that first feature? First feature, I have wider bandwidth. What do you mean by wider bandwidth? We know that what is a bandwidth? The bandwidth is, we have certain series of signals, frequency signals, certain range of frequency signals that can be transmitted through optical fibers. So here, if you take these optical fibers, their bandwidth is wide. What do you mean by wide? Suppose if I take normal copper cable communication, in non-copper cable communication, its bandwidth is around 500 megahertz. Whereas if you take fiber communication, in case of fiber communication, bandwidth, it is around 10 to the power of 5 gigahertz. So just try to notice the change. So what is our bandwidth? Range of frequency. Here I think range of frequency is very high. What do you mean by range of frequency being very high? What do you mean by having wider bandwidth? It means that at a time I can send many number of optical signals. So at a time we can send many number of optical signals. We can send around 15,000 independent optical signals simultaneously through the optical fibers. We can send large number of independent signals. And how many? It is possible to send around 15,000 independent light signals. That is nothing but having wider bandwidth. So this is the first attractive feature of fiber optics communication. Now coming to second feature, here loss during transmission of optical fiber is low. And why it is low, we have seen because total internal reflection, and then after that we are launching the light at angle less than maximum angle of incidence, which is nothing but our acceptance angle. And then we made one acceptance cone so that we have to launch light only within the acceptance cone. And then after that we made graded index fiber. So in graded index fiber, we have observed that even in multimode propagation also, dispersion will be very, very less. So all this will make transmission loss very, very negligible, even though very minor losses, attenuations associated with optical fibers. So transmission loss during transmission of signals is very, very negligible. Then coming to third advantage of optical fibers, electrical isolation. Now what do you mean by electrical isolation? Now if you see Electrical isolation. Generally, what is the medium we are choosing in order to send these optical fibers? The medium which are choosing to send optical fibers is fiber material. And what is our fiber material? Fiber material is generally a dielectric material. So medium that we are using in order to send signals, it's a dielectric medium or it is an insulator. Okay, so what will happen now when we are using such type of insulators? Then these particular fiber material, it will not catch any signals that are coming. Suppose if you have many power lines going side by side, then what will happen here? And also we can safely use them in explosive environments also. Why? Because the medium which we are choosing, it's a fiber material. Okay, and there is no hazard of shocks. And even suppose if it is storming, if there are any thunderstorms, because material is fiber, it will not catch those thunderstorms, or we can safely use them even when there is high current lightning also, so they will not catch fire, because medium that we are choosing in order to send signals is an insulator. So we can safely use them even in explosive environments also. There is no hazard of shock. Why? Because medium that we are choosing is a dielectric medium, so they won't catch fire even if there is high current lightning or any thunderstorms, and there is no effect of electromagnetic radiations also on these optical fiber cables. Then coming to fourth part, immunity to interference and crosstalk generation. Suppose I'm sending my voice through optical fibers. Generally, if you talk on phone, sometimes what will happen, we may be able to hear the person talking on some other line. That is called as crosstalk generation, or there may be some noise coming when I'm talking to other person. So that problem, it is called as crosstalk generation, or that generates because of interference of signals that are going parallelly. So if you have many lines going parallelly, there is a possibility that interference of signals will take place, and because of that you will have internal noise or crosstalk generation. That problem will not be there if you go for these optical fibers. So you will have immunity to interference, even though there are many signals going through side by side, and there won't be any problem of crosstalk generation. There won't be of interference of signals resulting in crosstalk, and there won't be any noise also. So this is about the fourth attractive feature of optical fibers. Then coming to fifth part, signal security. So what is signal security? See, usually when we use this copper coaxial transmission, in copper coaxial easily we can tamper current. So there will be possibility of tampering of current. But tampering of light signals through optical fibers is highly impossible. Why? Because when you try to tamper with our original signal, easily we can detect it. Why easily we can detect it? Because our original signal, it will get distorted. So once your original signal gets distorted, we can detect it and we can make out that the tampering is being done during propagation of signals. So that's why we'll say that there is signal security. We cannot tamper with the data that is transmitted through optical fibers. Then coming to sixth attractive feature of optical fiber, there won't be any voltage problems. If you take your normal copper cable communication, we have to go for proper earthing or we have to go for proper grounding. But that provision we don't need when we are going for optical fiber communication system. Why? Because material is a fiber material and our information, it is in optical form. Because our information, it is in optical form, we don't have to go for earthing and grounding. So there won't be any problem of voltage. And then coming to seventh part, what you will observe here is, of course, we know the dimension of core and cladding. It is very small. Their diameter, it will be in a few micrometers. So size of optical fiber is very, very small. Dimension is very, very small. And because they are made up of dielectric materials like glass and plastic, they are very light in weight. Whereas if you compare them with copper, it's a metal, it will be very heavy. So here, compared to the copper cables, here you'll observe that optical fiber cables, they are small in size and they are light in weight and they are flexible. So we can handle them roughly, we can bend them, we can twist them, we can roll them. And even though if we are doing all this, we are roughly handling it, there won't be any damage to inner core and cladding, even though it is made up of glass. Why? Because we are going for thick outer covering, that is nothing but our outer jacket. So we are going for thick layer of this particular black polyurethane, and that will protect our inner core and cladding from getting damaged. So this outer jacket, it will play the role of protective skin as well as it will give mechanical strength to optical fibers. So flexibly we can roughly use them. And here low cost, of course it is little bit contradictory statement, but here how we can justify it being low cost, because what is the material we are using to make a core and cladding? Material that is used to make core and cladding is our glass or plastic, and we know that glass or plastic, they are abundant, they are available in abundance in nature. So that's why, because of availability of material used for making optical fibers, that's why we'll say that that cost is low. And so because of all these attractive features, we'll observe that optical fiber communication system is very much best suitable compared to normal coaxial copper cable transmission. So today in our session, we have discussed about optical fiber communication system. Also, we have seen what are the advantages of optical fiber communication system. So now I'm going to end my session here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.